Welcome, CSEC students. Thank you for joining me for another live CSEC class. Today we're looking at algebra and we are going to continue our look at solving linear equations. So a linear equation will have a variable, and by the way, this is solving linear equations with one variable. Other methods we can use to solve variables, for example, solving simultaneous equations and so on. So we're looking at linear equations with only one solving simultaneous equations. So there's only an x. Even if there are several x's, we can combine them, but it's just one letter, x. Later on, or in other videos, we'll look at solving quadrans and so on. So the idea of solving linear equations is we want to isolate the variable. And by variable, we mean the letter that is there, the letter that we're trying to find the value of. Well, it's usually x or n or y. Those are common letters used, but any letter or any symbol can be used. So when we say that we're going to isolate the variable, that means we want to get that variable by itself. That means we're going to find some way of getting everything else to the other side of the equation. So the equation will have an equal sign and will have something to the left and something to the right. Probably we want the variable to be on the left. So we want to bring everything else to the right. It doesn't have to be, but this is just the standard way or the elegant way that we want to do it. And we want a positive variable, not a negative x or a negative y. We just want to find out what is x, what. So we isolate the variable by moving everything else to the other side. In order to do that, there are two ways of looking at it. You can say, well, I'm going to move everything to the other side, and once I move anything, the sign will change. You can look at it like that. Or so if whatever is positive on the left, if I move to the right, it's going to become negative. Whatever is negative, if I'm moving it across the equal sign, to become positive. You can look at it like that. If I'm dividing something, when I move it across, I have to multiply it. Or if I'm multiplying it, I have to divide. Or if I'm squaring it on one side, in order to move it to the next, I have to find the square root, and vice versa. So that's one way to look at it. Or we can say, all right, to cancel something out, we want it to be equal to 0. So if I have a +5 and I want 0, then I have to do the opposite of which is to take away 5. And I would have to do the sides of the equation because I don't really want to change the value of the overall equation. I'm just finding ways of manipulating the equation to solve for the variable, but I don't want to change the value of anything. So whatever I do to one side, I do to the next. If I'm subtracting something and I want to get 0, I have to add that thing. I have to do the inverse to get 0. And I do that on both sides. If I'm multiplying, I have to divide. If I'm dividing, I have to multiply. That kind of, those are two ways to look at it, but it's in essence, we are really doing the same thing. So we're going to some examples now, and I want to thank you, those who are joining us. The media you are using, welcome. I appreciate your comments and your participation. Post your questions, post your answers, post your comments as we go along. If there's anything that you're not getting, you can ask me to go over it. You can stop me right in my tracks and say, Miss, I'm not quite getting it. Go over it, and I'll gladly do that for you. So let's go. So we'll start with some simple ones. So number 1, x plus 6 is equal to 21. No, I'm actually going to do it both ways that I was telling you about. But from here on out, I'm going to do it the way that we just say, well, we're moving. Once you're moving the number to the other side, the sign changes, or the operation, we do the opposite operation. But I'm going to work both ways here so you can see. So, all right, so x plus 6 equals 21. The variable is x and by itself. It's already on the left, so that's good. We want it to stay on the left. So that means we need to get rid of the 6. We're adding 6. So the opposite of that is to subtract 6. And that would give us 0. But we have to subtract 6 as well so that the equation doesn't change. So what we're left with is x, because the 6 is now gone. 21 minus 6 is 15. So x is, if we plug that answer back into the original equation, it should add up. So if we plug 15 here where x is, 15 plus 6 does give 21. So that's how we know we're right. The other method is to say, I want to move something across the equal sign, and the sign of that will change. So this is a plus 6. So if I'm moving it across to leave x by itself, it's going to become 6 at 15. So this is the method I'll use from here on out. If you prefer this method to show step by step what you're adding or subtracting to cancel the other one out, that's fine. And some teachers will ask you specifically to do it like this. At the CSEC level, this is fine. So whichever way you want to do it. All right, number 2. We have 3 plus x is equal to 10. X is already on the left, which is where we want it. We like to have our variables on this side so we can have that variable equal to whatever the solution is. So we need to get the 3 out of the picture on the left. It's a positive 3. So we're going to move it across over here, and the sign is going to change. So now what we get, x equals 53. And that is 12. And if we back into the original, if we put 12 where x is, 3 plus 12 is equal to 15. Number 3, y minus is equal to 9. All right, so y is the variable. And we have a negative 3, which we want to bring it over to the right-hand side. We want by itself on the left. So since we are taking away, once we're going to move that 3 over to the right hand side, it's now become a positive 3. So we're going to have y is equal to 9 plus 3, and that is give 12 to 12. And if we plug that 12, substitute it back here, so we would minus 3, and that gives 9. So we know we're correct. Number 4, 8 minus x equals 12. All right, so we have 8 minus x equals 12. We want x over here. You can, since it's a negative x and we will want a positive x, you can move the x across so it becomes positive, and then move the 12. And then you just rewrite the equation switching places. Or you can say, all right, I want to move the x to the right, the 8 to the right. So I'll have negative x equals 12, and that will become now, and because we're moving it up, so negative x is equal to 4. Remember now, we don't want x. So get rid of that negative there. We're going to divide both sides by negative, and that will cancel negative. And we divide that by negative, which is negative. If we plug negative 4, substitute it up here, we would have 8 minus negative 4. When you're subtracting a negative number, it's the same as adding 8 plus 4 equals 12, and that is correct. Whenever you solve equations in algebra, it's always a good idea to answer back into the equation, the original equation, see if it makes sense. So here we have negative 6y is equal to 48. We are multiplying the negative 6 and the y. Whenever you see a variable beside a coefficient, they are being multiplied by each other. There's no sign separating them. So it's negative times y. So to move the negative 6 across, we have to do the opposite of multiplying, which is divide. So we're going to have y is equal to 42 divided by negative 6. And that is going to give negative 7. To check the answer, plug negative 7 here. Negative 6 times negative 7 gives negative 42. Remember, negative times negative positive. So that's how our answer is correct. The answer is negative 7. All right, so we have done 5 so far. Those in the chat, and so far, just say, I understand. Just type, I understand, if you get it so far. If you don't get it, let me know that you don't understand, and let me know where along the line you got lost. So remember, we do the opposite operation of the original operation that is there. We want to isolate the variable. We want to get it by itself, preferably on the left. If you can't get it on the left, work with it on the right until you get your final answer, and then just rewrite it, the answer on the right, the solution on the right. That is the standard way to express. So let's move on. So now to go to number 6. And number 6 says 2x is equal to negative. So we're multiplying the 2 and the x. So we want to move the 2 to the right to do the opposite of multiplying, which is to divide. So we need to divide. And I'm gonna work it the way I work number 1, just for you to see. If you want to say, all right, you're going to divide both sides by 2. So that would be that. Divide by 2. So you'd have x equals negative a quarter. Negative 4.5. And plugging that back in, 2 times 4.5 does give, 2 times negative 4.5 does give negative 9. Or the way I've been doing it is to say, so if we have the original, the way I is to say, we are going to move the 2 to the right, so we have to divide by 2. And that gives negative 4.5. Okay, number 7. X squared gives 36. All right, so how do we don't want x squared, we want x. So we need to get rid of the square. The opposite of squaring something is to find the square root. So you could say you find the square root on both sides. Do the same thing on both sides. The square root of x squared is just x because it's the square. And the square root of 36 is 6. All right. We could have just said, well, we have x squared. We want to move the square to this side. So we do the opposite, which is to find the square root. So x is the square root. That's a symbol, square root. When we say we want to find the square root of something, we're asking, when you multiply it by itself, it gives 36, and that's 6. Right? So 6 is 36. Number 8. The square root of y. The square root of y is 16. So we want to ask ourselves, the square root of what number would give 16? So the opposite of square root is square. So to get rid of the square, we would have to, square root would have to square. So y is equal to 16 squared. And 16 squared is 56. All right, let's go to number 9. So number 9 says 2x plus 3 equals 11. 2x plus 3 equals 11. All right, so this is just a little bit more complex. We have the variable and the coefficient here, x, and then we have a constant term here, 3. Okay, so I want to get rid of the 3 first from the left and bring it over to the right. So since it's a plus 3, sorry, why did I put a 9 here? So we write back the 2x. Since it's move it across to become minus 3. And that will 8. All right, so we're one step closer to home. So 2 times what give 8? We're multiplying by 2, so to move the 2 to the right, we need to divide by 2. So x would be equal to 8 divided by 2 gives 4. So x is 4. If we plug this answer back to the equation, so we would have 2 times 4, which gives 8, and 8 plus 3 is 11. We're 10 negative w minus 6 equals negative 1. Want to move the negative 6 across. It's negative over here, it's going to become positive. Move it across. And negative 1 plus 6, 15. So negative u equals negative 15. So if what we can do is we say we cancel both negatives, or we divide both sides by negative 1 to get rid of the negatives. Whichever way you want to say it. We have a negative w, negative 15. Negative is common to both, so we can cancel out both the negatives. So w is equal to 15. Say you're moving the negative w to the right, it becomes w. You're moving the negative 15 to the left, it becomes 15. So 15 equals w equals 15. Same thing. All right, so we have done 10 so far, and we have 15 of them, 5 to go. Hopefully, understanding, right? So we have done 10 so far. I keep stressing, let me know if you are not getting it, because that's the whole point of you being in the session, is to understand what is happening and ask your questions or comment as you go along, so that by the end of it, you would have learned something and you're more confident in solving the equations. Absolutely need to know how to solve linear equations at CSEC level. This is just the base, because you're going to have to take it a step up when you're solving 2 linear equations at the same time, simultaneous equations. So you have to have this down pat. You have to be very versed in basic solving linear equations. You have to have that to a point, right? So we have 5 more to go. is equal to 15. And now, to remove the 3 from the left, I'm multiplying 3 and p, so I'm going to divide by 3. So p would now be 15 divided by 3, and that's 5. Okay, 15 divided by 3. If we plug this answer back into the original equation, if we substitute 5 where p is, we would have 3 5s, 15 minus 5, and that would give 10. So we know that our answer is correct because when we substitute it back into the original equation, put that value where the variable is and multiply and work that option here, we get back the answer. Always plug in your answer in your algebraic equations to check. Doesn't take anything off you. You're not going to lose any weight. You're not going to lose it. Plug in the answer and check. Number 12, negative b. So this is a b plus 6. This one is a 6 equals 38. Start by moving the 6 to the right. So we have negative 4b. It's 6. When I move it to the right, it's going to become a negative. So I'm going to have negative 4b, and 38 minus 6 is 32. I need to get off the negative 4. I'm multiplying the 4 and the b. So I need to divide when I move it to the next side. I remember we do the opposite operation. If we add in, when we move it, become minus. If it is minus, when you move it across, it becomes plus. If you're multiplying, you're going to divide. If you divide, you're going to multiply. If you square, you're going to square root, and so on. So I'm going to have now 32 divided by negative 4, and that be 8. So remember, positive divided by a negative number will give a negative number. If we substitute this value of negative 8 back up here, so negative 4 times negative 8, that will give a positive 32, and 32 plus 6 would give a positive 38. So we know we are correct. Number 13. So 2x plus 3. So this one has a bracket. Throw it in a little niceness there for you. That one has a bracket. We are going to expand the bracket first. The distributive law, let's expand the bracket. So 2 times x, that's 2x. And 2 times 3 is, all right. I want to remove 6 from the left-hand side. Adding 6 now, so when I move it across, I'm going to be subtracting 6. So 2 times what gives? Multiplying 2 and the x. So when I move the 2 across, I'm going to need to divide. That's 10 divided by 2. And that will give, plug in that 5 back up here using substitution. 5 plus 3 is 8, and 2 times 8 is 16. Remember, the bracket here means you multiply whatever is outside the bracket by whatever is inside the bracket. So you can add the 5 and the 3, you get 2 say if you want to 2 times 5 is 10, 3 is 6, 10 plus 6 gives 16. It's all up to you. So now let's do number 14, and then we have one left to go. And these ones are really, really simple. So 4 divided by x is 25. So what we can do is we can cross. This is 25 over 1. We didn't have to write it, but if you prefer, you can write it. So cross multiply. 4 times 1 is equal to 25 times x. So 4 ones 4. 25 times x is 25x. So I want x alone. I don't want 25x. So I need to divide by 25 when moving it across. So it will be 4 divided by 20, which cannot be reduced any simpler. And we like variable on the left. X equals 4 over 25. All right. So 4 divided by 4 over 25. Plugging that in. So it will be 4 divided by 4 over 25, which is the same as 4 times 25 over 4. 4 is cancelled. So we'll, and that's what we had, 25, right? So that's how we check that we are right. And the final one for this session, number 15, x over 5 is equal to 100 over x. 100, sorry. And because we know we're going to be cross multiplying, you can put the 1 there, as well as at this level you don't really have to. But you know, x times 1, which is x, to 100 times 5. And it is 500. So x is 500. Plugging that back in, 100 divided by 5 does give 100. So that's how we check that our answer is correct. Whenever we solve our algebraic equations, so back in to check that we have done the right thing, right? We're correct. So the basic principle, whatever the linear equation is that you are given, we want to isolate the variable. And by variable, we mean the letter, the x, the y, the b, the a, or the symbol, star, the triangle, whatever you're using to represent the unknown quantity. We want to isolate it. We want it by itself. And we prefer if it is on the left-hand side. So that means we're going to bring everything else to the right. In order to bring everything right, we have to do the operation of what we started out with. The opposite of addition is subtraction. Opposite of multiplication is division. Opposite of square is square root, and so on. So if you're subtracting a number, when you put it across, you're going to add it. Another way of looking at it is to say, I'm going to add this number to both sides, because you have to do the same thing to both sides so as not to change the overall value of the equation. That's it for this today on solving linear equations. Remember to practice, practice, practice. Math is all about practicing. That's how you're going to get it right. And the more you practice, you will become, and the more your answers